AMD has released new details about future processors based on the Zen 6 architecture. The company issued a document, Performance Monitor Counters for AMD Family 19H Model 50H-57H processors, which the researcher noticed Inst L64. Formally, this is technical documentation for software developers, but between the lines, it reveals a lot of Zen 6 architectural details, including EPYC Venice server CPUs. The main conclusion is that Zen 6 is not an evolution Zen 5 and a completely new architecture with a different philosophy. If the previous generations of AMD developed gradually, then here the company bet on a wide architecture focused on maximum bandwidth and massive parallelism.
Key technical features of Zen 6 include 8-slot dispatching mechanism, simultaneous multi-threading technology. In such a design, two hardware threads dynamically compete for a common pool of dispatching slots. This is an interesting nuance. At the same clock frequency, the single-threaded performance of Zen 6 will not always exceed the performance of Apple's 9-slot or wider processors. However, in certain scenarios, such an architecture promises extremely high overall power. The presence of dedicated counters for unused dispatching slots, back-end downtime, and thread selection losses confirms that AMD is making the main bet on extensive command execution and SMT arbitration.
Special attention is paid to vector and floating point calculations. Zen 6 significantly expands the tools for monitoring FP and SIMD loads, which directly indicates the focus on heavy math problems. According to the documentation, processors support full-width AVX512 execution for the following data formats: FP64, FP32, FP16 to BF16. FMA/MAC operations, mixed execution of FP/INT vector operations including VNNI, AES, and SHA. Interestingly, the performance of 512-bit vector blocks is so high that AMD is forced to combine performance counters to measure execution correctly. This does not guarantee that Zen 6 will become the absolute champion of AVX 512, but clearly shows that the kernel is able to perform a very large amount of vector work per clock cycle, more than the old measurement methods predicted.
Previously, AMD already confirmed that Zen 6 will be manufactured using the 2nm TSMC class process, and that server configurations can have up to 256 cores. Combined with the new microarchitecture, this looks like AMD's first design built from scratch specifically for data centers, rather than adapted from client solutions. Information was also available on technical details of new chips. It is not yet clear which of these capabilities will persist in consumer processors and how they will behave in real PCs, but it is already obvious that in Zen 6, the main bet is made on massive calculations, server loads, and tasks, where not the peak frequency is important, but the maximum bandwidth.
The details surrounding Zen 6 clearly indicate that AMD is not resting on the success of Zen 4 and Zen 5. The decision to build the architecture from scratch, combined with the transition to a 2nm process, is an incredibly ambitious move that demands massive resources. This signals two major points. AMD is aggressively preparing to counter Intel's future tiled processors to maintain technological leadership, and we are looking at a massive leap in performance per watt and likely a significant reduction in intercore latency thanks to the new packaging. Zen 6 looks like the generation worth upgrading for in 2 years. This isn't just evolution anymore, it's a new era for Team Red.